So today we're going to talk about stem cell research. What is stem cell research?
If I'm correct, it's use of...
Bless you.
It's introduction of cells that have the ability to not reproduce but act in a certain way to help benefit the patient in growth and healing.
Okay, but all cells do that.
These are collected at a certain time, if I'm correct, either through use of the umbilical cord blood, or it's basically almost the purest form, if I'm correct, of those cells.
No, I said the purest form from umbilical cords, but you're on the right track. We're going down the right rabbit hole. Anybody else? Really? That's interesting. Waiting for someone to come in. Stem cell research has to do with cloning. It comes in two flavors. Everything seems to come in two flavors. One flavor is called therapeutic and one flavor is called reproductive. Any guesses for reproductive?
Insertion in utero, or when people are having a hard time giving birth, so to speak?
No, I followed that thinking. No, but that's not correct.
Where it can replicate itself?
Yeah. Reproductive is simply making a copy of itself. Nature does it all the time. Twins, triplets, quadruplets, quintuplets, does it all the time. Does it in nature when it comes to non-human things, and it does it to human things as well. I think it's Arctic bears have two almost all the time, just to preserve the race. My daughter's now raising Rottweilers, and that one has, I think her name is called Summer. I'm not sure why they would call a dog Summer, but I think she had 7 this time. She had 9 the time before. So nature's always trying to reproduce and make copies of itself. Not necessarily identical copies. You can get, I've mentioned that my fraternal brother's a copy of me. A fraternal copy, not an exact copy. I don't look like him, but he resembles me. Okay. So reproductive cloning, but therapeutic cloning is where the interest is right now. And frankly, the hope, and what they won't tell you is the disaster, and I'll show you all of it, and we can have our discussion about it. So this is really what we call parts therapy in its most generic form, in its most bland form, parts therapy. Okay, so what the hope is that we can make replacement parts for bodies that are in need of replacement parts. Sooner or later, your parts are gonna wear out, and it would be nice if we had a replacement part like a car. You just go someplace and you get a replacement part, and then it runs like it did when it was new, only it won't be new because you'll be mixing new with old. So that's in general what it's about. And the hope is that with cloning, especially therapeutic cloning, we can not only give people renewed parts to their body, but we can also figure out why parts don't work right, and maybe we can address diseases like Alzheimer's and ALS and dementia, get rid of blood disorders. I have a friend right now who's got blood leukemia. Maybe we could just do some stem cell replacement or therapy, and her blood would go back to normal again. So we're kind of hoping that we can kind of correct what nature hasn't gotten right. Okay, everybody understand that? Okay, now the problem with this is we have no idea what we're doing. We're playing, we're trying to figure out things. This is all research. I just went online this morning and asked what the advances were in what we call adult stem cell therapy. And it's all in clinical trials, and sometimes it works and sometimes it doesn't. So we had a fellow named, of course I'm not going to remember his name right now.
John.
No, the quarterback who played for Denver and won him a championship, but he played for the Colts. Peyton Manning. And he hurt his neck, and they took him over to Europe and tried some stem cell therapy, and anybody watched him play after that, he was still no good. He just got away with it. Let's put it this way, he wasn't like when he was young and in his prime. He was not restored to normal. But we're trying to make it work. And frankly, we do that with all other medical advances. We have to put them through research trials, clinical trials, to see if it'll work. Where it works, it seems to work. I bet none of you had polio. Nobody? Really? Do you know who Jonas Salk was? S-A-L-K, Jonah? Salk. He was the one who invented the polio vaccine. Literally was able to eradicate polio across the entire planet, except where we don't use it anymore, and then it makes a comeback. Bugs are more lethal than we are. But he invented the vaccine, went through a lot of trials, invented it. It used to be a shot, and then they gave you a couple of sugar cubes, and I don't know how they do it now. I don't even know if you get it anymore. Did any of you have polio vaccines when you were little? So they must have thought they eradicated. They didn't. It makes comebacks every once in a while. So anyway, it's research. Stem cell research. That's what we call it, research. We're trying to figure out if we can make it work on our behalf. So I want to show you a short little video. This is fairly comprehensive. You are not going to be tested on the science, but I need to lay the foundation so I can talk about the ethical issues with it. Now, the gentleman who's going to present this is almost